Hello girls, let us move on to the question number 4. The question number 4 states that prove that the perpendicular drawn from the origin to the tangent planes to the cone lies on the cone. So the question looks very complicated, but the solution is very simple to solve, girls. First we have to understand what the question is telling us. He's telling that I have to draw perpendicular is nothing but the straight line from the origin, and that straight line should come from the tangent plane. But tangent plane is lying on which cone? This cone. Lies on the cone, we'll understand that part later. Okay girls, so what am I supposed to do over here? Girls, if I'm going to observe this particular cone, if I'm observing it, its vertex is supposed to be the origin. That means this cone is having the vertex as the origin and this line is drawn from the vertex. So let us now start constructing the equation, this particular structure for this cone. So we'll see how the figure comes out. So he's telling that I have a cone. So this is my cone, and this cone looks in the form of ax square plus by square plus cz square equals to 0. And then from the cone itself, it is very clear the vertex is nothing but the origin. Okay, so what is it telling that I have to draw the tangent plane to the cone. Let me construct the tangent plane to the cone. This is the point of contact. Let this be the tangent plane through this point of contact. Okay, then what is it telling? Perpendicular drawn from the origin to the tangent plane. So from this to the tangent plane, I'm drawing a perpendicular. But from which way? Because girls, I can draw the perpendiculars from anywhere, but it's telling that I should draw perpendicular for this tangent plane only that is passing to the origin. Let me draw the perpendicular from the origin. If you look at this line will generate a cone. This cone is known as what? Reciprocal cone. If you look at this, the structure is coming from the same vertex. It's looking like the reciprocal cone. So in a very simple way, what am I supposed to construct? I have to construct the reciprocal cone for this particular cone. Hope I'm clear with this. So let me again read out the question. Perpendicular drawn from the origin to the tangent plane to the cone lies on the other cone. That is, the perpendicular is lying on the other cone. So basically, in a very simple way, I need to construct the reciprocal cone for this particular cone. So first I'm going to write down the given cone is equation 1. I'm going to implement equation 1. What do we need to find out? The reciprocal cone of the equation 1. So in order to find out the reciprocal cone, girls, for me, the values of small a, b, c and f, g, h should be clear to us. So now I'm going to just write down the general equation of the cone, and I'm going to compare my equation 1 with the general equation of the cone. If I'm going to compare, a is a, b is b, c is c, f, g, h is not present, so it's going to be obviously 0. Then I'm going to construct the reciprocal cone. What is the equation of the reciprocal cone? It's going to be the same as my general equation of the cone. The only thing is that it's going to be replaced with capital values. But then I have to construct the values of a, b, c, f, g, h. So how is a? bc minus f square. How is b? ac minus g square. How is c? ab minus h square. So we're going to plug in all the values. bc is bc, bc, capital B becomes ac, capital C becomes ab. Then what is g? hf minus bg, hf minus bg, 0. Similarly, capital F is 0, capital H is 0. Plug in the values of a, capital A, B, C, F, G, H into your equation number 2. 0, 0, 0, 0, 0, 0. This would be left out with bcx square, capital B is acy square, capital C is what? abz square. This is nothing but the equation of the reciprocal cone. So what the question says that I have to find out the reciprocal cone. I compared with the general equation of the cone. I picked up all the small values. I've written, I know the equation of the reciprocal cone. I've written the equation of the reciprocal cone, wherein I have to find out all the capital values of this. Finding all of the values, substituting back into your equation cone, I'm going to get the equation of the reciprocal cone. Hope I'm clear with this.